The history of DevOps, a comprehensive timeline from its origins to the present. Why you should learn DevOps. Learning DevOps not only enhances the efficiency and quality of the software development process but also positions you for future career success. 1. Improved collaboration. 2. Faster time to market. 3. Increased efficiency. 4. Enhanced quality. 5. Better risk management. 6. Improved customer satisfaction. 7. Career opportunities. 8. Higher salary potential. 9. Job security. 10. Constant learning. Job opportunities in DevOps. DevOps job opportunities are plentiful in India, with numerous companies seeking skilled professionals to fill various roles. DevOps engineer. Many companies, including Capco, Experian, and Tikian, are hiring DevOps engineers to design, implement, and maintain their cloud infrastructure. AWS DevOps engineer. If you have expertise in AWS, you can explore opportunities with companies like Astra Cloud, which is looking for talented AWS DevOps engineers to join their team. Senior DevOps engineer. Experienced professionals can consider senior roles with companies like Paytm Labs, Visa, and Experian, which offer challenging opportunities to lead DevOps teams and drive innovation. Job statistics for DevOps in India. DevOps market growth. The DevOps market in India is expected to grow at a CAGR of 18.95% from 2020 to 2026, reaching $12,215.54 million by 2026. Job demand. 68% of IT teams in India have an upskilling program in place, indicating a high demand for skilled DevOps professionals. Top skills. The most popular skills in the DevOps tech stack in India include Docker, 42.77%, Kubernetes, 28.02%, AWS, 12.1%, Linux, 9.17%, and Bash, 4.44%. Salary range. The average annual salary for DevOps engineers in India ranges from 1,200,000 Indian rupees to 2,500,000 Indian rupees, approximately $15,000 to $31,000. Industry adoption. 83% of IT decision makers in India have implemented DevOps practices to unlock higher business value. Job roles. Top DevOps job roles in India include DevOps engineer, cloud engineer, automation engineer, and release manager. Early foundations of DevOps, 1990s to 2000s. 1990s, the emergence of Agile and automation. The roots of DevOps can be traced to the growing need for faster software delivery and improved collaboration between development and operations teams. This was the era of the rise of Agile methodologies, which emphasized iterative development and customer collaboration over contract negotiation. In parallel, the concept of automation in software deployment and infrastructure management started to take shape with tools like Perl and shell scripting, which developers used to automate manual operations tasks. 2000s, continuous integration and collaboration. Continuous integration, CI, became a key practice in the software development lifecycle, SDLC, where developers began merging their changes into a shared repository several times a day to detect issues early. Version control systems like Git, Subversion, SVN, and CVS gained popularity for collaboration on code bases. The separation between development and operations teams remained, but efforts to improve collaboration were underway as businesses sought to speed up software delivery and ensure more reliable releases. The birth of DevOps, 2007 to 2010. 2007, the term DevOps is coined. The term DevOps was officially introduced by Patrick D. Boy, a software engineer and consultant, at the DevOps Days conference in 2009, although the discussions around collaboration between dev and ops teams were happening earlier. D. Boy, frustrated with the inefficiencies of traditional SDLC approaches, sought to bring development and operations teams closer together, creating a cultural shift that emphasized collaboration, automation, and continuous feedback to enhance the delivery pipeline. 2008 to 2010, DevOps Days and early community formation. In 2009, the first DevOps Days conference was held in Ghent, Belgium, bringing together developers, system administrators, and other IT professionals to discuss how to break down the silos between development and operations and improve the overall software delivery lifecycle. The event marked the beginning of the DevOps movement, where key principles like collaboration, continuous delivery, automated testing, and infrastructure as code, IAC, started to take center stage. DevOps grows in popularity 2010 to 2015. 2010, the rise of continuous delivery and automated testing. The concept of continuous delivery, CD, a software development approach that allows for automated, rapid, and reliable releases, was popularized by organizations like Netflix and Etsy. Tools such as Jenkins, Hudson, and Travis CI became widely used to support continuous integration and continuous deployment, CI/CD, automating build and deployment processes to ensure faster and more reliable releases. The rise of cloud computing platforms like Amazon Web Services, AWS, and Microsoft Azure provided DevOps teams with scalable infrastructure for managing and deploying applications in the cloud, thus accelerating adoption. 2012, the emergence of Infrastructure as Code, IAC. Infrastructure as Code, IAC, became a key principle in DevOps. Tools like Puppet, Chef, and Ansible allowed operations teams to automate the configuration, management, and deployment of infrastructure. This automation further bridged the gap between development and operations by making infrastructure provisioning repeatable, scalable, and version-controlled. 2014, the DevOps maturity model and agile adoption. DevOps practices became more formalized with the introduction of the DevOps maturity model, which helped organizations assess where they were in terms of DevOps adoption and what steps were needed to improve their processes. Agile methodologies also began to blend with DevOps practices, with teams adopting both to enhance development velocity and quality. Leading companies like Amazon, Google, and Netflix became well-known examples of DevOps at scale, showcasing how their rapid deployment practices and automation led to innovation and competitive advantage. 2015, DevOps and Security, DevSecOps. The concept of DevSecOps emerged, integrating security into the DevOps pipeline. This allowed teams to address security issues earlier in the development lifecycle, rather than treating security as a post-development concern. Organizations realized that security must be part of every stage in the DevOps pipeline, emphasizing the shift-left approach, where security testing and validation are done during the development process, rather than after. DevOps maturity and expansion, 2016 to 2020. 2016, the rise of containers and microservices. The containerization revolution, fueled by Docker, significantly impacted DevOps. Containers allowed for lightweight, portable, and consistent environments for developing, testing, and deploying applications across different systems. The rise of microservices architecture further enhanced DevOps by allowing teams to focus on smaller, more manageable services, which could be independently deployed and scaled. Kubernetes became the de facto tool for orchestrating containerized applications, enabling efficient management of distributed systems and services at scale. 2017, DevOps tools and platforms. The popularity of tools and platforms that supported the DevOps lifecycle continued to grow. Some of the key tools that became integral to the DevOps toolkit included Jenkins for continuous integration, Terraform for infrastructure provisioning, Kubernetes for container orchestration, Git for version control and collaboration. Organizations began to create dedicated DevOps teams to support continuous delivery pipelines, enabling more consistent and rapid software releases. 2018 to 2019, the adoption of Site Reliability Engineering, SRE. Site Reliability Engineering, SRE, emerged as an extension of DevOps, with a focus on improving the reliability, scalability, and performance of applications through automation. The term SRE was popularized by Google, and many organizations adopted its principles, creating roles specifically for SREs to monitor, optimize, and automate infrastructure and operations. 2020, DevOps becomes standard in software development. By 2020, DevOps practices were considered a mainstream part of modern software development and IT operations. Companies that had embraced DevOps were able to deliver software faster, more securely, and with fewer errors. With the ongoing rise of cloud services, containerization, and microservices, DevOps became an essential part of creating highly scalable, resilient systems. The future of DevOps, 2021 present and beyond. 2021, the push towards AIOps and automation. AIOps, artificial intelligence for IT operations, began to gain traction, helping organizations leverage machine learning and AI to improve incident management, monitoring, and automation across the DevOps pipeline. The goal of AIOps is to automate the detection and resolution of issues, allowing for faster problem solving and improved system performance. DevOps continues to evolve to focus on continuous improvement and feedback loops, where every iteration leads to more efficient workflows and faster deployments. 2022 and beyond, DevOps and multi-cloud or hybrid environments. With the increasing use of multi-cloud and hybrid cloud environments, DevOps practices had to adapt to manage the complexity of working with different cloud providers and services simultaneously. Cloud-native development and serverless computing models further push DevOps to evolve to support scalable, efficient, and cost-effective infrastructures. The focus on security, compliance, and regulatory requirements will likely continue to grow as part of the DevSecOps movement, integrating security practices even deeper into the development lifecycle. Key milestone summary. 2007 to 2009, the birth of DevOps through the introduction of the term in the first DevOps Days conference. 2010 to 2015, the rise of continuous delivery, cloud computing, infrastructure as code, and DevSecOps. 2015 to 2020, the integration of containers, microservices, and Kubernetes, alongside the expansion of site reliability engineering and the growth of the DevOps industry. 2020 present, the continued adoption of AIOps, cloud-native architectures, and serverless computing in the DevOps ecosystem, with a strong emphasis on security and multi-cloud management. Conclusion. DevOps has transformed from an experimental practice to a foundational part of modern software development. By emphasizing collaboration, automation, and continuous delivery, DevOps has led to faster, more reliable, and scalable software deployments. With continuous advancements in cloud computing, containerization, and AI-driven automation, DevOps is poised to evolve further, becoming even more essential for organizations aiming to stay competitive in the digital age.